CV hasn't changed over the years, and the one bit that I've always just thought would never change would be having to be optimistic about supporting Manchester City, but how things have changed. Thank you very much. A warm welcome to all of you. Many thanks for joining us tonight, and it's a terrific attendance. I know from talking to Paul, we've actually had to turn some people away. So it's great to see an audience, and an audience drawn from academe, from business, from schools and the general public. I hope you all enjoy the evening and you enjoy the lecture. I'm particularly pleased that RSC and the CIA are joining forces for this, the last public lecture in the Chemistry Centre during this, the International Year of Chemistry, and I believe it's the third lecture delivered by Procter Gamble as well. Many of you will be RSC members, and some of you will be employees of CIA member companies. Just so you're aware, CIA is the trade body for chemistry using businesses in the UK, and I run that trade body. Our focus, everything we are about, is making the UK as attractive as possible as a business location for chemistry using businesses. And there's a key opportunity right now, as tough as the climate is, in terms of this focus on rebalancing the economy and a commitment to science and manufacturing, the language that is being used by politicians, and how do we make that tangible? Now, the opportunity, I think, is about enabling people like you and companies that I represent to not only deliver economic growth, but to deliver the solutions to society's challenges in terms of food, energy, transport, health, and, of course, water. Now, only a couple of weeks ago, the global population reached the 8 billion mark, with growth of 6 million people a month. Alongside that, well over 1 billion people live in areas already affected by water scarcity, and demand for water is expected to rise by over 30% by 2030. All of this contributing in part to this perfect storm that our chief scientist has talked about, alongside the 30% more energy demand that we're going to face by 2030 and the 50% more food demand by that date too. So it's against that backdrop that it gives me great pleasure to welcome our guest speaker tonight, Professor Phil Souter. I think Phil will speak for us for about 45 minutes, and then we'll take questions for about 15 to 20 minutes on the quest for a clean drink. Phil is a scientist at Procter Gamble and will discuss the challenges faced in making potential water sources, lakes, ponds, wells, floodwater drinkable using chemical technology. I think during the lecture he will touch upon the impact of unsafe water on people's lives, particularly in some of the world's poorest countries, and how water purification technologies have been designed to effectively and cheaply clean up dirty water sources. Phil will also explain how collaborative projects and networks are now working together to get the PuR Purifier of Water products to the people who need it most, and the impact this can have. This event, I think, also will be broadcast live on the Reaction website. So, Phil is a section head in the Household Care Global Business Unit of the Procter Gamble Company. He graduated with a degree in chemistry from Oxford University in 1991 and received his PhD in organic chemistry from Oxford in 1995. Subsequently, Phil was a postdoctoral research associate at the University of Virginia, before he joined P&G in 1997. Within P&G, Phil spent several years working on water purification, culminating in the development of the PuR Purifier of Water product, for which he received the John Smale Innovation Award in 2000 and the National Inventor of the Year Award in 2006. He is the author of over 20 scientific papers and numerous patents and patent applications. He has extensive experience working with suppliers, universities and research institutes, and manages a global group of 20 people focused on developing new technologies for household care products. He is currently a visiting professor in the chemistry department at Durham University and has recently been admitted as a fellow of the Royal Society of Chemistry. He lives in Northumberland with his wife and 2 children. Ladies and gentlemen, Professor Phil Souter.
Okay, well, good evening, everybody. As Steve touched upon today, I'm going to cover a variety of things with you. One is what it really is the global need for clean drinking water. I'm going to talk a little bit about a product that we designed against this need, talk a bit about the scientific challenges, how the product works, a bit about what effect it has on people's health, and then for the last part of the talk we're going to focus a little bit on how do we actually get the product to where it's needed, the importance of partnerships there, and the impact it can have in an emergency relief context, and then maybe speculate a little bit about the future moving forwards. So in terms of the consumer need, which as Steve has already told you, more than 1 billion people today lack access to safe water. And for the UN, they've reported roughly 80% of diseases are water-related, and the biggest single killer of children in the world is a lack of access to safe drinking water. It's estimated about 50% of infant mortality is caused by dirty water. Diarrhea alone, which is one of the key things that you get when you drink dirty water, kills over 3 million children every year. So that translates to 5,000 a day. The other thing to talk, the UN has issued some Millennium Goals, a little bit out of date now, but just in order to achieve those goals, to give you a sense of the magnitude of the task, they're looking to provide safe water to 125,000 people a day. It's a huge, huge endeavour, and it's something where, as a global society, we're really struggling to keep up with demand. So there are many different approaches to how you might choose to go clean up water. What I'm going to start with is just to show you some of the water that people are drinking around the globe. And the main sort of take-home message is that the quality of water is pretty poor in many parts of the developing world, in particular where it's very scarce. In terms of what are people doing, we actually found, as we looked into it, the consumer habits are actually remarkably similar across the globe. So if we ignore people who have tap water, obviously having access to cheap, safe tap water is the best solution you can possibly have in terms of providing clean drinking water. But if you go to a wealthy economy like the United States, there's still 10% of the population who don't have tap water. It's simply not economical to treat water and pipe it across huge distances in North America. If you take those problems out into the rural parts of the developing world, it's very clear that there will never be global access to tap water. So in addition to a lot of excellent work that companies do to try and provide clean water through municipal treatment, there is actually a need for products that the consumer can use themselves. Some of the key insights we found was that actually when we first started looking at the product, we thought, well, it would be very difficult trying to design for different dosages around the world. In practical terms, everyone's kind of carrying the same amount of water, and it's just simply dictated by how much you can carry. Everyone doesn't want to make multiple trips to their water source. It can often be a long way away. It can take a number of hours to get there and back. So people carry as much as they can. And the comfortable amount is about 10 litres, roughly. Typically two lots of 10 litres, or one lot of 10 litre on the head. We faced a number of barriers. A lot of people are unaware that water makes them ill. They've drunk it all their lives, so have their parents, their grandparents. Culture, a lot of people believe that water is a gift from God, so how can it possibly be bad for them? Diarrheal disease is very much a fact of life. People are unaware that there's a way to avoid it. And even where treatment's occurring, we did a fair bit of research to say even when people are claiming to treat water, the actual number of people treating water is an awful lot lower. So some of the habits like boiling, chlorination, filtration, precipitation, are claimed habits, but they're really not happening that often. And if you've ever had to boil water, starting with collecting wood, making your fire, and then boiling it and having it available, boiled, and then cooling it down, it takes an awful lot of energy and an awful lot of time to achieve. Water sources are used for a lot of things. So here's some people doing their washing. This is the same water source they're drinking out of as well. So the actual levels of contamination that you're looking to remove are quite high. Another typical water source, just a pond here. And this is a fairly common habit in Africa in particular, where people are actually carrying water back on their heads. As you can see, a fairly standard size of container. So I'm going to start off with just a little video kind of showing you, oops, that didn't work, a little bit about people's habits. Okay, so that video is actually from a partner organisation, Students of the World. But and the important thing I was looking to show you there is actually, if we look on a global basis, water is very much both a women's issue but also a children's issue. If you look at who's actually going out to get the water, it's mainly women and children. And it has quite a big impact in terms of the amount of time they have to do other things, which can mean the difference between an education and not an education. And as a company, a lot of the products we make beyond this, things like laundry products and so on, are another source of water usage that people have. And the more we can do to minimise the amount of water they need to use and minimise the number of trips they have to make to the water source, the more positive impact it has on the ability of women to work where they want to, and also the ability of children to attend schools. So even the sort of simplest things in some ways can actually make a huge difference to life out there. So coming a little bit to the product, I mean, in terms of what we were looking to try to do, really we'd had a look and we'd figured out that most people were, roughly speaking, what they could carry was about 10 litres. So most people were looking to treat about 10 litres of water at a time. And what we were looking for was just a simple, inexpensive way to treat any kind of water that our consumers were looking at. Why would P&G invent such a thing? It kind of fit very well with our P&G purpose. I mean, our stated company purpose is to improve the lives of world consumers, and this obviously fit very well with that. And, above all else, I mean, the consumer need is very apparent, especially for anyone who's travelled in the developed world. I mean, you can really see it, and, the statistics and figures are all out there for everyone to see. So, in terms of what we were looking for, there are 5 key restrictions we needed to put on our invention. It needed to be very cheap. If you're thinking rural consumers primarily in the developing world, it needs to be very, very cheap. It needs to be easy to use and intuitive. We needed some kind of a signal for the consumer that something had happened, that this product was working. And then there was a whole bunch of performance criteria. I mean, it needed to be effective. If we had a look at some of the key things we were looking to remove, things like bacteria, viruses, and cysts that cause disease, things like heavy metals that cause other sorts of diseases. And also just in terms of, if you look at water, and I have some water over here, we're going to have a go at cleaning up in a sec, it doesn't look terribly appealing to drink water like that. It's not terribly appealing. If you can find a way to clarify and get rid of a lot of the chemical components from within the water, it obviously makes it much safer and much tastier to drink. The other thing that the drinking water world is rightly very tightly controlled in terms of regulations. EPA, the EU, the WHO all have regulations associated with any water treatment product, and you obviously need to comply with all of those. And from a safety profile, you're quite limited in the palette of chemicals that you can throw at this problem. They all need to have obviously an excellent safety profile, environmental profile, and typically you need either a drinking grade or a food grade ingredient to go into such a product. So those were the challenges. So I'll talk a little bit about the chemistry. I'll show you in action. So all these long words on the slide actually end up meaning something. But essentially, what we were looking to do was to take what actually happens to your tap water today. So tap water tends to be treated in by water companies, and they use a series of steps to do that, depending upon the water source. So they use what's called coagulation, flocculation, and disinfection. And then the key things we were looking to drive were these. So I'm going to get this going. So the product's quite simple to use. Just add it to water and stir away. I'll try and show you what all these things are. So the first key ingredient in the product is something called ferric sulfate. It's a primary coagulant. And the idea of this is basically all rust is. Rust is basically precipitated ferric. When you add that to water, it starts to react with the water and starts to precipitate. As it does that, is that any better? Yeah, probably. Okay. As we start to do that, you'll start to see this. Well, maybe some of you can't see it. I have to take my word for it. There's very little particles starting to form, and that's the process of coagulation. What's happening there is basically that ferric sulfate is taking a lot of the impurities in water and starting to precipitate them out. In terms of sequencing chemistry, in a water purification plant, you can choose to add the chemistry at any point. One of the big challenges we had was it needs to be a one-size-fits-all solution, and all the chemistry needs to be timed. So we use a very low particle size to get a very rapid dissolution rate, so the thing gets to work straight away. The next piece is flocculation. I'll come on to show you that in a sec. But producing these fine little precipitates in here is all well and good, but it's not terribly easy for a consumer to remove them. And a second part of the product, which will come to life in a few minutes, is called flocculation. That's basically taking all these small particles you've formed, linking them together into a big particle so they're quite easy to separate. Disinfection is another key thing. So in the same way that your tap water is chlorinated, this product also contains a source of chlorine. Here actually we were looking to do the opposite. We were looking to actually delay the release of that a little bit. Reason being, if I could precipitate out a lot of the harmful materials, I don't waste my chlorine reacting with those. I can use it to do what it's supposed to be doing, which is disinfecting the bacteria and viruses. And then finally, the other key ingredient, we have a very low level of potassium permanganate in there, which is an aesthetic aid to clean out any stray impurities of iron and manganese in the water and make sure it's nice and clear. So, the product, relatively straightforward. Source water, you add the product, you filter it through cloth. You can also just decant it as well if you don't have a piece of cloth, but most people have got a piece of cloth lying around in the home. And the idea is you end up with clean, safe water ready for use. In contrast to a habit like boiling, there's also a residual protection, which is quite important, because if you're batch preparing 10 litres of water for a family of, say, 5 people, you may only be getting through about a litre and a half a day, so you may well want it lying around for a couple of days. The residual chlorine in the product helps protect you and makes sure that the water is safe to drink for a couple of days at least. So to show you a little bit of the product in action, this is Lake Victoria on the right, and these were a string of samples that I picked up on a field trip in Kenya. I went there back in 2003, I think it was. And the nice thing is you can take any of these kinds of water and clean them up. So if you look at the dam water on the left, it's kind of almost surprising to me as a chemist that so much stuff can actually suspend itself in water. If you leave it overnight, you do start to see some sedimentation, but the clay out in that part of sub-Saharan Africa is amazing stuff. And it sits in the water for a long, long time. We were able to take the same set of samples and show that we could remove all these things from those waters, which was a key step for us in terms of really validating it works in the field. So sorry, if we come back to look at the demonstration here, you can start to see the particle size is starting to grow as this bridging flocculant kicks in. You can stir this as many times as you want. The particles will get a little bit bigger now, and then they'll start sedimenting to the bottom, so we can strain them off. So, in terms of product targets, in order to qualify as a purifier of water, you need to demonstrate at least a 6-log kill on bacteria, at least a 4-log kill on critical viruses, typhoid, polio and hepatitis. And you need to show that you're able to remove parasites like Giardia and Cryptosporidium. These are kind of quite important. They're quite hard to kill. So traditional routes like chlorination don't actually work on these things. But what they are is they're quite big, so they're actually quite easy to precipitate out. So these get more removed actually by the precipitation than by the disinfection. Another key aim of the product was to really make sure that we could remove heavy metals. If we take a country like Bangladesh, there were a lot of efforts went in to provide safe drinking water in Bangladesh in the 70s in particular, where an awful lot of wells were dug in the country. Bangladesh had one of the worst rates of infant mortality from drinking unsafe water. Unfortunately, as they dug the wells, they uncovered a second problem, which is that the soil there is very full of arsenic. And it took a while to figure it out, but this is the kind of effect on the right that arsenicosis can have on your hands. It's a very, very unpleasant disease, and it's not curable. So very important also that your product takes out heavy metals such as arsenic and lead, and the ferric sulfate is extremely good at doing that. Organics and pesticides as well. So I'm going to kind of close out a little bit on the science piece now, and in terms of what were the technical problems we needed to solve and how did we go about them. And then after that I'm going to move on a little bit more to how we're going out and deploying this technology now. So in terms of some of the key problems, it's, well, how do you do one size fits all? I mean, you saw the slide with the waters from Kenya. You've got this sort of dark brown soup all the way through to something that looks clear and kind of looks okay. In actual fact, the technical solution to that was maybe not necessarily obvious, which was actually to add more dirt. The difference between cleaning up something that's, pretty dirty to very dirty is a lot easier a spectrum than to go from clean to very dirty. So one of the things we have in the product is just dirt, if you like, or clay. And this actually provides the seed particles for coagulation. And what you'll see as I run through how the product works, really the key to designing a good product is to keep it simple. So the more ingredients you can have that are multifunctional, the better. It's cheaper to do it that way for a start. But also, the less ingredients you've got, the less things you have to interact with each other. And the more things you have interaction with each other, the more chances you have of things going wrong. So these clay particles serve several purposes, but one of them is to provide seed particles. So effectively you have an insoluble there. I was describing to you how this rust starts precipitating. It starts to grow on these clay particles. So you start to build particle size before the polymer kicks in and grabs them all together. It's also there to stabilize our critical ingredient, which is our source of chlorine, as I'll come on to. Sequencing in the chemistry is very important. If that polymer release that grabs all the stuff before all my precipitates have formed, the product wouldn't work. If the chlorine came out too early, the product wouldn't be as effective. If the aesthetic aid came out too late, it again would be ineffective. So even within a product, you have a lot of means at your disposal. And they're mainly driven by particle size and particle form. But even using the same basic chemicals, having the right processes happen at the right time is critical. And then how to stabilize an inherently highly unstable active. And actually, when I look back on it, this maybe, didn't particularly think it at the time, might have been the most important invention in the product. Because, as I'll show you, I mean, there's only one globally regulated solid source of chlorine you can use, which is calcium hypochlorite. It's inherently highly unstable, and you're looking to ship this product into some of the warmest countries in the globe. You can't do it with the raw material. If you try to purify the raw material, the only way you can really do it to get the water off, there's water inside the calcium hypochlorite which catalyzes its decomposition. The only way you can get that off really is thermally. As you start to heat it up, the product starts to decompose, so you're kind of stuck. So all the grades are sold with about 7 to 10% water in them, and that water is the catalyst to decompose the chlorine. So what we managed to achieve with this product was actually in product very gentle desiccation. And I was like, you know, I mean, this again was achieved through the clay, and it was achieved through drying the clay down to the point where it had less than 1% moisture. It then acted as a moisture sink. It dragged the water out from the chlorine, but it also, as importantly, it locked it up, so it just wasn't available in the product. And as a result, you take something that has a very short shelf life to something, as we'll come on to, has an extremely long shelf life. The other thing is it's a nice system in terms of, you know, we're able to establish rate constants and quantitative models. So to show you a thing here, and I apologize, the RM means raw material, that's the actual chlorine. If you look at the blue and green lines, you can see basically all my chlorine's gone after half a year at 40 degrees C. Whereas if you actually take the product, it's less than 5% of it's gone. And, you know, we took this out to 2 years, and we were still below 20% had gone over that at 40 degrees C, which is quite warm even for warm parts of the globe. So, yeah, we've been able to take something that didn't look like it could be done and take the key active and actually make the thing stable. This is actual data on the product. The other thing you can do is you can actually monitor and predict storage stability very accurate, because it's quite a well-behaved system. So if there are any chemists here, if you've ever been taught the Arrhenius equation and thought that will never come in handy, it actually did come in handy here, which is, you know, the R-squareds on this thing are a measure of how linear they are. These are the actual data off the first 2 sets of products we made. And I mean, an R-squared of 1 is perfect match. I mean, you rarely come across data with error that's that accurate. What that means is we have a very good understanding for exactly, I mean, if someone comes to me and says, the ambient temperature is 33 degrees centigrade, we can predict exactly how long the product will last. And that's obviously very important in terms of if the product's going to be warehoused in parts of the developing world, it can reach quite high temperatures for brief periods of time. And just knowing that those storage conditions, we can actually predict what's going to happen to it. Okay, so that's kind of the science bit. I think I mean, you can probably already see, but you know, I'll filter a bit of this water for you. I could filter the rest, but that will probably do. Yeah, so you have a nice, clear water sample. So I must admit, the first time I saw that, I was quite impressed. But it's always quite impressive to see the chemistry in action. Okay, what do I do with the clicker? Here we go. So that's all very well. You can get a product, it can work well. But what I learned early on in this project is when you actually give that to people, some very different things can happen. So, I mean, you can see this is the product here. It has some lovely instructions on the back that are very pictorial. Our first product didn't have those lovely instructions that were very pictorial, and we actually went out with our very first product execution with writing on the back of the pack into a very early test market, and discovered that actually there were only 2 out of the 100 people we exposed it to who could read. So it wasn't the most useful set of instructions. So we learned pretty early on, you've got to make sure it's pictorial, and you've got to make sure it's obvious. Nice thing with this product is you can stir that as many times as you want, the precipitate will appear. So yeah, the instructions we basically give are stir until you get big lumps that settle at the bottom, and then filter. And you know, that's translated pretty well through the globe. So I'm going to just walk you through a clinical study we did the Center for Disease Control did in Karachi, Pakistan. So, I mean, this is the type of environment we were looking at. This one was actually a more of an industrial setting, but squatters. This was their basic source of water. For those of you who are microbiologists, this is a lot of fecal coliforms, which is, you know, some of the main disease-causing microorganisms. You know, the segregation in a lot of parts of the developing world of sewage water from drinking water is very, very poor, and as a result, you know, they're rife with disease. This was the basic backdrop. Oops, I clicked one too many. We had 10% of children below the age of 5 dying, 40% from diarrhea, and huge amounts of malnourishment. And the diarrhea actually contributes quite strongly to the malnourishment, because if you can't keep any food in, you know, it's very hard to build weight, even if you are getting food. So this was a joint venture between HOPE and the CDC. The HOPE led the field team. We went to 1,300 families, and we actually studied this one out for 39 weeks. I'll come on, we did a clinical in Guatemala for 52 weeks, and we've done some others in Liberia and Kenya as well. So if you really want to understand what impact an invention has on people's lives, you've actually got to study it over quite a long period of time and see whether or not habit change sticks, because it's all very well having clean water for a few weeks, but if you then go back to your old habits, it's not really been a success. One of the problems we encountered, which is a classic problem for these guys, is that, flooding. And if I just even look at the tap water, during the, before the rains is on the left, during the rains is on the right. The problem is a lot of the taps are leaky. Surface water basically comes in and fills the pipes. I mean, if you've got constant positive pressure in your pipes like we do here, it's not so much of a problem if you have a leak. But in huge parts of the developing world, the tap water supply is only on for a few hours a day. It's often piped next to the sewage supply. Pressure goes, the water kind of all mixes together along with anything coming in from the surface. And, the actual quality even out of tap water that people were getting at that time was pretty poor. Results we found were, surprisingly good, actually. The diarrhea rates were down 53%. You should say, well, that should have been 100, shouldn't it? But, waterborne disease is not the only cause of diarrhea. So if in practical terms, you go out to that many families, I mean, some of them are going to use the product, some of them are going to claim to use the product and not. And, we could tell just by the number of sachets that are gone that, some of them were using it all the time, some were using it some of the time, some weren't using it at all. So in a clinical setting, to actually have a 53% reduction in the rate of diarrhea is pretty good. We actually ended up doing 5 global studies on this across more than 25,000 people, which cost us a few $1 million. But we were actually able to show and use this data to really show that the product worked. Also, I mean, although in the lab I can get 99.9% arsenic removal, we found that people treating the water themselves, and again, you can't be certain when you go get the samples from their homes that they have treated it. We were still seeing an arsenic removal of more than 98% in the field, which meant that we could never show whether the last 2% were people who hadn't treated or hadn't used the product well, or the arsenic source was so high that it couldn't get rid of every last trace. But for a field result, that's actually pretty good. So we had a good product. We've been able to show it worked. So how do we go about commercializing it? I mean, the first experiment on this product was conducted in 1999, towards the end of the year. And we're actually able to put it into test market within 2 years of the first experiment, which in our terms is quite quick. It took us about a year to get the product the way we wanted it, and then about a year to kind of scale it up to an industrial scale. Our test market results were not great. Procter Gamble is like a fast-moving consumer goods company, and typically we target quite high repurchase rates. That's our business model. We really struggled via our traditional P&G routes to make this product a success. And the key thing we struggled with was consumer habit change. We're typically used to going in somewhere, advertising a lot, telling people about the message, them getting it, encompassing in their daily lives and moving on. Here, we saw this in a lot of the clinical studies. It's actually quite a phase, all about education, education, education. There needs to be a constant education message here, because most people are unaware that water was made in the middle in the first place. And then they needed the education on what it could do. They needed to see their neighbours using it and see what difference it made to their lives before it would become a habit change for them. So, we did try in a few test markets in Guatemala, Philippines, and Pakistan. But we came to the conclusion, actually, we weren't the best people to make this product available, which sounds a bit odd from a large consumer goods company. But what we were finding is most of the people who needed this were way outside our traditional distribution channels. And we really, really struggled for distribution in test markets. And during the course of our investigation, we'd partnered quite a lot with non-government organizations, various charities. And we actually found that they were much, much better at doing this than us. You know, if someone is going into a community in Africa with a health message, they can have something on water purification, they can have something on sexual health, oral rehydration, whatever other medicines are needed. There's an economy of scale of someone going in, establishing that distribution chain across multiple products. Trying to achieve it on one product is very difficult. And, you know, bear in mind, we did everything we could to keep the cost of this product down. I mean, a sachet like that would treat 10 litres of water. That's enough for a typical family for somewhere between 1 and 2 days, depending upon the size of family. That costs 2 pence. So there's not, you know, a whole lot of, you know, of money sloshing around to do advertising and education. And the more of that you do, the more cost you're putting onto the product. And at the end of the day, one of the goals is to keep the product cost low. So we kind of flipped it on its head a little bit and changed direction. So, I mean, the focal program of the focal focus point of the program really has been to become part of our corporate philanthropy efforts. And we established something called our Children's Safe Drinking Water program. It's a not-for-profit business, and it's conducted now by our sustainability department. And basically, we've moved from an all-out commercial selling model to basically working with partners to get it where it's most needed. The model is we typically provide it at cost. They then provide it on at cost. But then we need to find ways for it to work in the developing world, and I've got a little video I can show you about that. And the other big area we're using it in is emergency relief. A lot of the standard solutions, I mean, chlorine can't be air freighted, this can, so if you need to get something out in a hurry, if there's been an earthquake, a hurricane, whatever, this is a great product to do that in. And as I'm starting to learn, you know, it typically tends to be 1 or 2 emergencies a year. You can never tell where they're going to be, but they do tend to crop up a lot more regularly than you might think. So another video.
Procter Gamble's PuR Purifier of Water is desperately just like the ones that will feed you. The retail prices of people, but not free.
Okay, so a good illustration there of one of our partner organizations, Population Services International, and how they're approaching this in Kenya. Lots of different examples from around the globe, but one of the key points the guy made there, which is true if you talk to any anyone who's worked in the region. Key thing is the local people need to make money. Model doesn't work otherwise. If you give people stuff for free, they're very, very suspicious about it. They don't think it has a value. And the people then distributing it aren't making any money either, and so they struggle to do that as well. So pretty much universally it's accepted now that you need to find models like the ones that we're employing where, all right, the companies in the West aren't making any money, but the local distributors are, and that's the way to get the distribution channels so that you can get the product out to the people who need it. So very, very different from sort of mass storage in warehouses and the like, down to these really local distribution channels that could be some guy on a bike, going around some of the jungles in Kenya. Emergency relief is another important part of the work that we do. Pretty much most major disasters that occur in the world, this product is going out to now. Here's some of the examples of the things over the last few years. We've now been able to collect the data through a US organization, the Center for Disease Control. They monitored the use of PuR in Haiti after the hurricane. And, because we're used to maybe selling it through the channels like PSI, like we showed, where there was always someone to talk and explain it. In disaster situations, the product needs to get out really quickly. So having people out there on the ground really monitoring that it was being used correctly was great. And, it was actually more, Johns Hopkins University conducted a clinical study in Liberia in a refugee camp. And probably the critical thing in a refugee camp is really to make sure you have access to safe water. They typically set up these massive swimming pools in which they store the water. And typically, once someone gets a disease in these refugee camps, it spreads like wildfire, and it's all spreading through the water. So cholera in particular and diarrhea are hugely prevalent in this scenario. Using this product in that case, we're actually able to drive more than a 90% reduction in diarrhea, which if you think water isn't the only cause, was really quite impressive. So in terms of, where do we have mass marketing, if you like, in the globe? We've got existing programs in more than 14 countries now, working with organizations like PSI, UNICEF and various others. A lot of work in community-based groups, schools. Schools education is probably one of the critical tools, actually, to making sure you can make a sustainable change. If you're teaching the children, often they're involved quite heavily anyway in the purification of water in the house, but if they're able to bring it back from the school and start to educate their parents as well, it can be a great way to create habit change. And also, from a sustainability point of view, more product we've got available, that is creating jobs in parts of the developing world. And because the people selling it are making money, it's actually sustainable for them as well. Kind of a couple of areas, particularly helpful for people who are suffering from other diseases as well. HIV/AIDS is, we have some studies of people using this. Obviously, they're more prevalent to picking up diseases anyway. So this is something that a women's group in Kenya are pushing quite hard, where they're really making sure that it's available in AIDS clinics to help those people live a bit longer and more positively. I know Paul Matz from P&G was one of the speakers here earlier in the year, has also done a lot of work looking at skin care and wound care. One of the big problems in the developing world for wound care is if the water's contaminated that's breaking the barrier where your skin's broken, that can lead to more complications. So having a clean source of water is actually important for a whole source of other medical issues. So this is the world as we see it now. So it started off back in 2001 with a little dot just about here in Guatemala, and it kind of spreaded this sort of orangish colour is the countries we're in today. So as you can see, kind of Asia and Africa dominated, but that's also where you will find the highest rates of infant mortality and disease from water as well. So getting the product out there hasn't been easy. We've now counted up more than 110 partnerships that we're involved with to try and get the thing moving. Of these little sachets, we've now sold 382 million, which is great, which equates to 3.8 billion litres of water. And then there was an institute in Latin America did some calculations, so basically pooled all our clinical data, and we're able to calculate based on that, you know, for every packet you sell, how many days of diarrhea do you avert, and how many, you know, lives you save as well, because in a couple of the clinicals, actually, the, you know, statistically, we broke, you know, the people who were involved using the product, they had less deaths than the control group who didn't. So, now that's the impact we believe we're driving today. We've announced in the last 12 months a new goal, and that's to basically save one life every hour. It was jointly announced at the Clinton Global Initiative, CGI, in this last year, and that's our CEO, Bob McDonald. And in order to do that, we need to provide 2 billion litres every year in the developing world by 2020. So you can see we've provided 3.8 billion to date. We need to accelerate. So to do that, we're actually building a new plant in Singapore to give us some extra capacity to meet those goals. But those are stated company goals now, which is good. And then yesterday, actually, I was a bit of a fraud coming to talk to you about PuR Purifier of Water. It's changed its name as of yesterday. So it's now going to be P&G Purifier of Water. So this is the first time P&G has put its name on any brand for over 100 years. So, you know, that's a big step forward for us as a company. You'll be familiar with an awful lot of our brand names, you know, from Olay to Ariel to Pampers and so on, but, you know, you're probably not so familiar with the company behind them. So for the first time, as I say, in more than 100 years, we're actually going to put our brand name on the packet. And I have another video to show you about what we're looking to do across some of the rest of the globe. Okay. Right. Okay, so if you want to know any more, and obviously I'm happy to take some questions at the end, but I'll also leave you a little website there that's got an awful lot of resources, information, how you can get involved if you'd like to, you know, on the whole program. As you can see from the last video, very nice to hear a lot of our partner organizations in terms of the impact that they see the product having. And with that, I'm done. So thank you very much for your attention. And if you have any questions, I'll be happy to take them.
Thank you very much, Phil. And real great examples throughout of tangible solutions coming through chemistry, and good that chemistry is associated with good. We have got time, I guess, for 15, 20 minutes of questions, so we will get to. I think we've got microphones that will come to you. I think that's right, is it? Just checking at the back. Yes, I think so. And when they come to you, I'll point you out. If you could just introduce yourself, and if you're happy to say if you represent an organisation or an institution, please do so. But we have, I think, one question, which is third row back on the right-hand side. Thank you.
Thank you. I'm Andrew Rickson. I'm a public health doctor. I was wondering, what place do you see this for the long-term provision of safe drinking water? Is it a model that you would see that would be sustainable for a long time into the future, or is it mainly around emergencies? There's also the concentration of the contaminants. How is that dealt with, all that arsenic that you're taking out? And finally, have you seen any false products being made yet?
Good questions.
Those were 3 questions.
Okay,
yeah.
well, I'll try and answer them in turn, if I can remember what they all were.
Oh, no.
So in terms of do I see it as sustainable, yeah, I mean, I think the answer is yes. I don't think it's the only solution. To be honest, especially if you live in an urban environment, the best solution there is the solution that we have here, which is clean, safe tap water. Now, some places are an awfully long way away from having that. I'd see that as the best long-term solution in an urban setting. But this can provide a very nice interim solution there. But ultimately, the cheapest and best way to do it in an urban situation is to have municipal water treatment. In terms of rural environments, I see this as something that will last the test of time because, as I was saying before, even in the US, 10% of people don't have access to safe drinking water. This is a cheap way to clean up your drinking water, and we think it will last, but if something better comes along, great. I mean, it's but I think this will last the test of time there. 2 other questions: how do we deal with contamination? To be honest, for most of the things, it's straightforward. So if it's just bacteria and the like that you're taking out, this stuff composts pretty well in the soil. In actual fact, we don't really push it, but it's quite rich in minerals, so it's probably not a bad fertilizer as well. But in places where you do have unique problems with chemicals leaching out of the soil, all you're effectively doing is just returning to that soil. So you're not, unless people are then going to set up a system to segregate the waste, which could be set up, you're kind of at least making sure it's not going in their bodies. But you're not. It's only if you actually set up a system for the waste as well. The problem. But actually, if you keep the waste in an area where it's not exposed to the deep deoxygenated environments of wells, it will sit there perfectly happily as well. But the key problem with wells is they're very strongly deoxygenated, and they'll actually take the arsenic that's locked up in that product as arsenic 5, iron arsenate. It'll actually get reduced to arsenic 3, which is more water soluble, and that comes into the water, and that's the big problem that you face is trying to remove that arsenic 3. So even if you actually as long as you don't end up burying the stuff, it won't get back into the water supply so easily. And there was a third question, sorry. Counterfeit products, yeah. We've not seen any counterfeiting of this. It's pretty cheap. So we see a lot of counterfeiting of our shampoos and perfumes and all these sorts of things. We've not seen any counterfeiting of this. We've seen other people try to put products on the market that, offer a partial solution, but we've not seen anyone else try to offer a full solution. We've seen people come out with, when we launched this in Pakistan, our competitors came out with chlorine tablet, which, takes out the bacteria, but doesn't help you clarify, doesn't help with the cysts and so on. So we've seen other people dip their toe in the market, but we've not seen anyone come out with a mass product like this.
Thank you, Phil. Next question. There were many hands before, and now there's... right, very good. Can we take the gentleman 4 rows back on this side, and then the gentleman at the back of the room afterwards? Thank you.
Thank you. My name's John Bocock. I'm a biologist with a particular interest in environmental education. If you had a high-profile facility say in central London, where you could show the sorts of things that you were doing, preferably hands-on, where the public in general could come and see what you're doing, but also young people who might be drawn into the fields of chemistry, biology and physics. Do you think you could put on, shall we say, a display, ongoing project rather than simply a display? The Science Museum, incidentally, doesn't have any space for things like this.
Gosh, well, maybe. Yeah, I mean, it's a good question. But we certainly use this as part of. We have quite a big schools program within the company, so we do a fair bit. Tends to be more local, admittedly, at the moment. So, where we're based in the country, we run programs at the local schools, and I mean, in addition to demonstrations like this, we also do a whole bunch of other things, showcasing some of the chemistry that's inside various of our cleaning products and so on, as a way to try to motivate youngsters to take up chemistry. But versus your specific question of have we thought of setting up something in central London, we haven't looked into it. No.
But I mean, that's a good question on so many levels, whether it's primary school, children, potential employees, the extent to which they're interviewing you as corporates about your global credentials, and the general public as well.
Yeah, I think in general there's a bit of a suspicion of big business and chemical industry by the general public. So I mean, I do, I think if I interpreted the thrust of your point, I mean, I do take it, I think it is a good thing for us to try and get out in the community and show that actually, science can be useful and it can be a force for really driving impactful changes on people's lives.
Okay. Thank you. It was right at the back of the room and after. Right.
Richard Port, Royal Society of Chemistry. Could you tell us a little bit about the expertise that you use to develop the product? Because I assume this comes from developing certain product areas at P&G over many years, and I wonder which kind of products those were.
Yeah, well, I invented this 2 years into my P&G career, and I'd started in our analytical department, so I wouldn't say there are a lot of aspects of what P&G does that helped in this product, but I think some of it is a fresh pair of eyes. I think a lot of people who work in the water purification industry are chemical engineers, because that's our model here. We build, super units that municipally treat our water, and that's what we do. There are very few chemists working in the area, and so I guess one thing I'd say, I brought a chemist's eyes to the problem. The other thing is we are good at making powdered products. We have a lot of process expertise in how to produce a box of Ariel or whatever, which is one of the key products on my site. So in terms of being able to access the right kit to be able to make the thing in pilot plant scale and so on, characterize it, and also in terms of basic water understanding, there's an awful lot of water understanding goes into our cleaning products, because the first thing they interact with typically is water, whether it's hand dishwashing, laundry, etc. And we really need to know and understand what's in that water and control it where needed, such that we can deliver good quality cleaning. And actually, this program came out, back in early '99, I was looking at how to recycle used wash water with a very similar kind of goal, which was we'd identified these consumers that were having to traipse 5 miles back and forth to pick up their water. We thought, well, it'd be great if instead of throwing the water away, they're able to reuse it to rinse or to do other jobs. So I actually started working in, I think it was April '99, on that problem. And then as I got more and more into that problem, I thought, it's an awfully hard problem. It would be a lot easier just to actually take the source of water they had and convert it to drinking water. And at about the same time, my company wanted me to change jobs to come up with new businesses outside of what we were doing today. So it's kind of a little bit of a match, really, of a lot of traditional P&G things we do well, the right opportunity, the right job, fresh pair of eyes, and that's often all it takes.
Thank you. There was a question 5 rows back on this side of the room. That gentleman at the end. Thank you.
Hello, Philip Dobson, Berkhamsted School. Teaching. This fits in absolutely with one part of the GCSE syllabus about water for all. And I don't know if I've been unaware and not having my eyes open to advertising, but how do I get hold of some of your material so that I can demonstrate, and then going back to your previous question, sir, inspire youngsters to see that chemistry in context is life-changing?
Yeah, I mean, there's a whole load of resources on the website I've shown, which is here. I think if that is insufficient for your purposes, then get in touch. You know, as I say, we do a fair bit in terms of our schools program on this, but it's not, we've not yet taken it to that next stage of like engaging and getting it into national curricula and so on. So, yeah, I mean, you know, get in touch and, you know, I think it's something we could certainly look at.
Thank you. Question on this side.
I'm Adam Ben-Raber from Thames Water. What do you? Well, it's a great product and it's it looks to be very successful. But what do you see as the major blockers to make it even more successful? Because the numbers, you know, there's great potential for global expansion, even beyond what you've done. But what do you see as the blockers?
Yeah, I mean, distribution channels, a huge blocker. I mean, you know, probably the easier places to tackle tend to be the urban environments, but that tends to be where municipal treatment solutions are probably the best. You know, just urban because there's lots of people live in a small area, mass distribution is a lot easier. Targeting rural parts of the developing world is very, very tough, and the biggest problem we hit was a combination of education and distribution channels. So, I mean, I think our partner organisations all do a fantastic job in terms of really helping us get out there and mainly getting out there themselves to do this. But yeah, I think that's probably the biggest barriers we face still. But you know, you often see with products as well, they kind of get a bit of an S-curve shape on adoption, and you know, hopefully we're going to hit the steep part of the S-curve at some point. You know, I mean, there are plenty of other business models that governments in the developing world could look at, right? I mean, I think if you get big enough trials, you can start to really show, you know, the impact of something like this on GDP and try and actually persuade a government, actually, you know what, just pay for it for people because it will pay you back in terms of the taxes you get in. So something like that would be really big and breakthrough, and then if one country did it, maybe it would spread to others. So I think there's plenty of ways that this could become a bigger idea, but, you know, it's kind of, I wouldn't say slow progress. I mean, we're making progress, but it's a very, very tough area to deal with, and huge problems on distribution in particular.
Mm-hmm. Thank you, Phil. There's a question on that side of the room.
Jim McKenzie, I'm retired, or semi-retired, but I've worked in water chemistry for a few years. Is there any way this could be used to clean up seawater, for instance, or is it just...
No, it doesn't. It doesn't touch. It doesn't touch sodium chloride. So no, it doesn't. In the same way that standard municipal treatment doesn't. No, you need to go to basically distillation, reverse osmosis, those kinds of things to clean up seawater. So it's not a viable option for that.
Question right at the front. Yeah, just 1 second.
My name's Douglas Hutchison. You've obviously got to get almost into bed with some people who may think that chlorine itself is the devil's element. How do you get to persuade people who may be indoctrinated or have listened to the anti-chlorine lobby that chlorine actually does save lives in the way that you do it? I know that when one listens to an emergency appeal sending water purification product out, they very seldom mention chlorine's actually involved in some way on a molecular basis. But how do you cope with NGOs too far removed from, let's say, any scientific understanding?
Yeah, I think we're helped by sort of health intervention studies or clinical studies, however you like to describe them, of the type we did, where people can kind of see it, you know, it works. So that can be a strong influencer. I mean, I know it is a difficult position, but I mean, I think most scientists, if they look back at and see what the Victorians did for us at the turn of the last century, I mean, installing chlorinated water into our homes was probably the single biggest positive impact on public health we had in the UK. And we basically see the same stuff from health interventional clinical studies in the developing world as well. So I know chlorine does bring with it some baggage in some people's minds, but we still haven't found anything. Well, in chlorine dioxide is another, and ozone and so on. But I mean, apart from those, there's really nothing else that's as effective. And I think it's easy to kind of turn your nose up at chlorine a bit if you're sitting with very nice clean drinking water. When you're looking at some of the waters these people are drinking, I think a lot of the balance does shift on that debate.
Yeah.
And sorry, just to close on that, I mean, obviously, some of the byproducts of chlorine are very tightly regulated, and with this product, as with your own drinking water in the house, we've obviously had to make sure that those byproducts are down at a very low level.
I think just on that one, the extent to which you can get other credible organisations articulating the value, you will always have single issue or single product pressure groups that the very reason for being is to outlaw that. But the more you can get credible voices speaking and highlighting the overall sustainable benefit, so you're taking the economic, the social and the environmental concerns and values around that, the better. But the other issue I think for companies to just accept they have to deal with is that you can't just pick up and drop advocacy on this. I mean, some of you may remember that going up and down tube escalators not so long ago, there was an advertising campaign around the values and the benefits that chlorine did bring. We ran that for about 6 months, and it had a significant impact. You've got to just keep doing it and doing it and doing it, and that's a real resource stretch. Question at the back.
All right. James Pethiker, a recent graduate. I was just wondering, you said that a lot of people considered water to be one of the things that God gives us. I'm not saying that's my position. I'm just saying, how did you deal with that? What sort of cultural things did you have to overcome as a company to get that out there?
Yeah, I mean, it's not in all parts of the world, but it's definitely a huge barrier to water treatment in some parts of the world, is that, if you view it as a gift from God, then, how can it be impure? And again, I think it comes to a bit of education. You're not disputing that the water God gave them was pure. It's just the mess that we're making of it that's the problem. So again, it's a question of education. But a lot of our partner organisations are extremely adept in dealing with these questions of making cultural change. But it's not easy, and especially if your drinking water source is clear. The kitchen logic isn't there to say it's contaminated if your family's been drinking it for many, many years. So it's only really, and this is the other thing, is you need the local credibility, and this is what a lot of the partner organisations really bring. If P&G kind of goes in there and starts talking about it, we it's not that we're wrong, but we lack a bit of credibility if the people don't know us. A lot of the people have been working in these countries for 20, 30 years. The message coming from them is a lot stronger, but it's not... there's no easy solution to it other than education.
Mm-hmm. Mm-hmm. Any other questions or comments? Well, thank you very, very much, Phil. That was a marvellous presentation, and I think we should honour that in the time-honoured fashion with a significant round of applause, please. If I just look at the UK context and the day job, and we're short of water, I'm encouraging my members and members in the UK to conserve water. Costing and pricing of water in a UK context is going to significantly ratchet up the agenda, and then we look at some of the global solutions that you as a company are delivering worldwide. I think it's fascinating and challenging and interesting. I'd like to have asked you a question about, will we see more P&G branding, but that's probably a little bit unfair. So perhaps we can have a chat about that over what I think is more tea, coffee and biscuits at the end, but thanks very much, everyone, for joining this lecture and for your questions and your interest. Thank you.
Thank you.